Okay, so hi everyone, and this is Paul, and I also one of the member from Accomdemy community, and Selman is also the co-founder of the Accomdemy, and some of the Accomdemy members from Taiwan, India, and Singapore, Malaysia, people they are also here. So also have some evangelists here. Happy to have you, everyone, and just want to do a very quick introduction about this community. So our learning community is called Accomdemy. It means that a company plus academy. So we are a nonprofit co-learning community. And what's the reason we start this community? Because since last year, it was COVID situation. So people, they are feel like very lonely in stay at home. And we know that if you are want to trying to learn some new things, it's so difficult and it's a little bit lonely that you want to start everything from zero. So there is a group of people that engineers, artists, founders, and designers that accompany each other to learn a lot of new technology, including embedded system AI, computer vision, audio, 3D printing, and even we co-create the project together, creating some design the logic gate and do some PCB layout, even a very cool RISC-V based CPU within 10 weeks. And even the other topics like KitKat or MicroPython, IC design, something like that. So you can also visit our website, accomdemy.org, and know more about all our following events and also the learning resources we have. And some of our alumni, they come from different big companies, including Microsoft and also Microsoft, MicroPython, Actor, Edge Impulse, Realtek Amoeba, ARM, C Studio, etc. And we want to make everything, learning materials and resources, open source. So you can also see that our resources page, which is we will have different kind of learning series. So you can see that now we got the TinyML learning series. And in the future, we also would like to have a chance to make everyone who are interested in the IC design, we can co-create a learning guide and tutorial and make it open to make it as an open source to everyone who are interested in that. So hopefully after today's sharing, if you are interested in the IC design topic, then we can group a study group. And the study group can be 8 to 10 weeks. And we will try to learn how we can start from zero to really submit the application to Google MPW program. So that is something that we will expect for and hope that it's very valuable to everyone. And also want to share something that we also have a Discord server. So now we got a Taiwan Discord server and international Discord server. We got more people from Taiwan. As you guys know that Taiwan is a very a good place that you can easily learn and really build and realize your IC design. But we are starting to have more people in our international Discord. So later on, we will also share our link for our Discord link. So if you want to keep the discussion, we can keep the discussion in Discord. There are different kind of channels, including sometimes we will get some giveaways from different companies. And also if you want to do some project, you can find a project partner here. And now we can put all the discussion about the open source silicon in the open source silicon channel. So feel free to join and also let's discuss and make it fun on our Discord. So I will give the time to Selman and Mohamed to let them share about our today's main topic. Thanks.
Yeah. Thanks, Paul. Thanks for the introduction and thanks for sharing about Accomdemy and what we are doing right now. So great. And yeah, we can start right now. And first of all, I invite all and thanks for joining everyone to joining the learning session of learning the how to make the chip designing. So as you know, like our main speaker is Mohamed Kassem, who is the CTO and co-founder of Efabless. And Efabless, one of the companies who is working with the Google MPW program and making the chip design, and they're also partner with the Google to sponsor free microcontroller design for the like students and hobbyists who make the design open source. So I'm not going to waste any time. I invite Mohamed Kassem to share his like presentation, and I'm also excited to learn about chip design. And meanwhile, presentation, if you have any doubts or questions, you can post on the chat. At the end of the session, we will actually going through the questions and we will try to clarify that. Yeah. Over to you, Kassem.
Okay. So I hope you can hear me and see me well.
Yeah.
I'm traveling, so my audio setup is different. And okay. So thank you very much for having me. And I've been very excited about talking to the community here. And it's actually consistent with what Efabless does. And during my talk, I will be just giving a little bit of background about myself and then the company and why we exist. And then I'm going to highlight some of the things we're doing. And heads up, it's not going to be as very technical session deliberately. My objective here is to get everybody aware with the bigger picture. And as was mentioned earlier, we'd be very excited to actually be a part of the organizing sessions to get the community members here at a more advanced or make more progress on doing specific projects of their own. The one thing I'm going to say up front is that after this presentation, what I'd like you to think about is that the main thing here is to show the world that chip design is doesn't have to be as complicated as it is perceived to be. There are many reasons why it's actually looking like this, and some of the areas in the chip design can be better introduced and understood, and allowing a lot more people to be able to do the work and benefit from chip design. So, excuse me. So I'm going to share the screen very quickly here. Share. Okay. So I will start. The presentation's title here is the preface by open source for a good reason, because open source, anything, if done correctly, it means open sharing, open collaboration, and knowledge sharing, as well as work sharing, and enabling everybody to build upon each other. And actually, before I remembered something that I think it's worth mentioning here. So I'm going to go to a website that it's actually available, but it has a story around it, and it will be very relevant to actually talk about. So this is a website for a company called Stone Soup Labs. Okay, so this is the original name of Efabless. And Stone Soup Labs, for those who don't know what a stone soup is, a stone soup is it's based on a fable that a group of travelers, they went to a village and they were looking for a meal, and there was no complete meal available in that village. So one of the travelers said, I'd like to make a stone soup, and basically put some stones and in water and started to boil. And then people will ask if, what are you making? He says stone soup. So they added ingredients. So they asked him for, can you bring in some carrots or potatoes or until the different people from the village and the travelers added ingredients from their on their own, and it made a soup that everybody had. So this was the original name of the company, and still, it's a coming on the horizon. But the principle of the company is having a community collaborate together to build things that would otherwise not exist without the community. So that is the premise, and Efabless is anchored around that, is to be able to enable the community to do cool things through collaboration. And I say cool here, meaning either innovation and new ideas, or actual new development and work that is useful for the society. So, so about myself. So my background is hardcore chip design, and I'm showing here a bunch of devices that are at least 10 years old. But that's where I actually, I left. I used to work with Texas Instruments, and I was responsible for building the analog on devices like what you see. We were working on the phone applications processor. And actually, it existed even before the iPhone existed. So some of these devices are older. And so that's why my responsibility at TI. And I have a mixed background of design automation, as well as hard SoC design, on analog on ICC design. I'm an avid tear downer. So I learn a lot from buying things and exploring what they are, understanding what they're composed of, and what engineering decisions were made, and also cost decisions and design decisions. So altogether, it's been very, it's a very useful experience to learn, and also maybe get ideas about improving some of the existing products. So everything we do as humanity, so we are a community. So, and this community, at the end of the day, there is the fun aspect of working together and coming up with new ideas. It would be even more fun if we can actually, maybe remove the word industry here, but actually society, and actually say that there are needs that the society need from that the electronics and the chip design in electronics in general actually can improve lives or benefit many regional needs, depending on what they are. So I'm not thinking here about a specific product. I'm thinking about any ideas that have come up from the community to solve a problem that exists that end up improving something in these areas. And it could, as you can see from the pictures, anything applies. There are many movements in the world to be able to build, especially on the open source side and the maker community, to build hardware from existing chips. Now, because it's actually kind of very costly and expensive to think about how to use. Think about it as the chip is a building block that if you knew how to build it and change it, you would have more ability to improve your product. And you can decide whether or not to use it. So in the process, in the semiconductor world, we use the transistor, minimum transistor length here as the kind of a metric and compaction. So the smaller the transistors, the more you can stuff in a chip. And at the same time, by doing so, the cost of this engineering becomes much higher. And then just naturally, when things get very expensive, it means that the number of capable entities or people goes down. And that means that the number or potential pool of innovation, or the community that it has access to such a technology, is smaller, much smaller than, for example, the hardware movement or the maker movement, right? So it makes the innovation pool, I'm not going to say limited, it's limited with respect to the larger view of embedded hardware development, for example, or hardware development in general, and compared to software in general as well. So it's much, much better. So if you look at the one of the sides of this concept here is what's called the long tail. So making a chip. So if you look at one of these applications that we talked about here, and you need to actually somehow, it would be beneficial for the design to be made, make a custom chip. The decision to make it is fundamentally, there is a lot of the reasoning behind it is to the cost for low volume. So these are this is like the left here on the left here. This is like the products that sell very high volume, like the smartphones, etc. And then there are so many applications that they will fall into this category that don't sell millions and millions of units. Think about it as like the books. Some books sell millions of units or copies, and some books, they send 10,000 copies. But for a specific application or specific community that are readers that want to specific topic. So think about hardware and chips as such in the same way. So there are many applications that require low volume, and that low volume, if the cost is too high, then you're not going to be able to make a chip for it. What we need to do is to reduce it so much so people can do it. Now, there is a concept that I want to introduce here, is what's called right-sized compute and power. Typically, you would work in using standard parts that are available from the industry and to build your hardware. And the standard parts, they are families of products. They have, I will call it like a quantized availability. So you can go to the menu, find this part does this, maybe how much memory, how much flash, and how many cores, etc. So you can select these, but there are in order for this, by definition, the standard products, they need to be able to support many applications for it to be economically viable for the company that's making it. So it almost may never be the right size, the compute and power. So by having a custom chip, other than it's cool and something that you can actually innovate with, you can tailor exactly what you want for your application. So we believe that as a company, that there should be a multiplier of 1,000x more people to be able to design chips for smart devices for the right reasons. So that's what we want to see. And in order to do that, we're not going to, in order to do these things, typically in the history, you don't go generate so many engineers that do the same thing, and you abstract. So you start saying, okay, how do I simplify it and use the technologies like the software technology and the progress in this other domains or disciplines to make it available. So it's like innovation in cars. It doesn't matter what's under the hood, but it works. And then you have a steering wheel and you're using it to do something with it. So we want to simplify the process and make it available for everyone. And that simplify, when I say everyone, I would call it, anyone that is willing, not anyone that knows, because anyone that's willing can always learn. How do we do that? In our multiple vectors. The knowledge is limited. So there is, even though on the internet, there's a bunch of documents and videos and all, but there's still a limited knowledge for the whole picture. There was, I will say, now it's not the case. And then the technology itself. So if you want to design with something now, if you want to go build a PCB, you can go get some design the PCB and send it to manufacturing and come back with their. So, however, in the semiconductor space, it's not as easy. You'd have to have the technology is considered, technology information is considered a competitive edge. So it tend to be hidden from the world. And then, of course, the manufacturing cost. So one of the things that are examples that actually show how things can be, the 1000X can be achieved, is what happened in the app stores. Before the app stores, whether it's anywhere, any type of app store, whether it's the Google Play or Apple App Store or others like F-Droid or these app stores, before they exist, in order to build the software application, you're gonna have to develop it, find other people to work with you, and then find the market for it and the customer. And then that process was very taxing, and not everybody knows how to do it. So it creates a barrier for people to develop software. When the app store showed up, there is a development tools, unified and qualified, and there is a business process how you can actually develop and do quality control on the application and connect to customers. The process basically, it went from it could be thousands of companies, it became millions of developers, and all of them can actually develop something and put it into the marketplace. That includes also kids. When I say kids here, because I mean age is not a metric, but it's basically, it says that it made it so simple that someone who is focused on developing an app and they know how to develop something innovative, very something very innovative, to put it in the market and actually see what people want. So you can do the same with chip design, except there is the concepts of so-called the PDK, which is called that similar. This is the technology information that is needed, as well as the software. And there's a need for the same thing, having a customer and an ability to do that. And we believe that can happen, and it started to happen. And if you think about it, is that if you have a community, or a global community from all sorts of places doing all sorts of things, and you give them the tools and the platform and the medium for them to work, and you have, and I say customers here, customers, we believe that this is the way actually innovation keeps getting measured. So when you develop something and it gets applied, the customer could be a farmer you're solving a problem for them to increase their produced productivity or. So this, what's in the middle here, can be used in two ways. One is you can actually develop something, the community would choose and develop something and then put it in the marketplace and share it, and other people can use it. And then there's what I call the pull, where the farmer needs something, but they don't know how to solve the problem. And then they would be able to share a request for it, and then the community would collaborate to solve that real problem. I'm using an AND gate here for the logic. Obviously, all of us in an AND gate, in order to work, to give you a 1 at the end of the right end of this AND gate, you need all the inputs to be 1. Any one of them is a 0, you get a 0 on the output. So there are many components that are needed to be able to produce or develop something useful that can make a difference in a relevant application. So there is knowing what the need is. This is actually market need. What could be the farmer, could be the doctor, could be some, whatever. And then the knowledge. Not all of us know everything. So I certainly don't. So I always want to collaborate with others to give me to cover the multiple disciplines that are needed for a chip. We need software, we need PDK, and also at the end of the day, we need the cost, reduce the manufacturing cost. So there are partial solutions. You can see them around the world. But what we wanted to do as Efabless, we actually solve the whole problem head on and address all of them. And we, without looking and trying to read the fine print here, in order for these to be resolved, there is the expression of open source across the board, whether it's open source IP, open source knowledge, open source tools, open source PDK, solves a lot of these problems. And I'll just skip a couple of things. So if you think about it, and it looks like that's what we wanted. We wanted to have a medium where people can collaborate and learn and introduce innovation, whether it's hardware or software, and keep that dynamic, the wheel running and increasing, speed. So how do we simplify it? One of the simplifications is the project we've had with Google. So this is, we approach Google to basically to fund the opening of SkyWater 130 PDK. SkyWater Foundry had the initiative to think that this is potentially good for their business, actually, because the PDK is the process design kit, and it's available. It would be this is the information about the design that you need to know to be able to design. So it is, or the information about the process, rather, or the technology. So it's like you're building something with wood. You need to know what type of wood and how you're gonna deal with that wood in terms of tools to carve what you want. So we started these the so-called PDK, which is the process design information, the design kit, was always under NDA. You had to go through a process to actually get it, and it's very hard to get it. Actually, it was very hard for these processes. So through the collaboration between SkyWater, Google, and ourselves, the PDK was opened in the open source domain, and then a year later or so, maybe actually 18 months later, again, Global Foundries, which is the second largest foundry in the world, or maybe third, they have also added to the open source portfolio another technology where other people can use. And then just recently, the US government publicly announced that they will fund a process in 90 nanometer in the next year or so. You can always go to GitHub. This is the beauty of this. If you go to GitHub, you're going to find that the different links for the different processes, and that includes all the information, the documentation, and mechanisms for you to ask questions and see how things work, including how to use it. And just going back to the slides, and we can address that as we go forward. So, and this was actually just saying, because some people were saying concerned that a 130 nanometer or 180 nanometer are not as advanced as those what you hear about the 7 nanometer or 3 nanometer or the Apple 5 nanometer for using it for the iPhone processors. I just wanted to remind people that you can do a lot, like including 180 nanometer. You can do a very high-speed processor, and you can work from there. It is very important also to see that the community around the process technology. So this is a slide from data from Europractice. They're doing a great work, but also one of the things they provide is that the summary of the projects that they have all over the year. And if you think about it, like 50% of their tape outs or designs are in the older nodes. So one of the things you can take a look at is always go to efabless.com/projects to see some of these. Now, speaking of community, so when the process was actually released in the first time, which is the PDK, it went viral in a sense. So if you look at this is the GitHub stars for major projects that are existed for years, and these are in the same space related to either FPGA or some software like for chip design, like OpenLane. And you can see the PDK it went viral and spiked up in 1 month, went to all that to reach something that has lasted for years. And it stayed to continue. This data is a little bit old, but it stayed to continue to have about 300 times a week call it actually about 150 times a week of downloads, which is very much more than what it was under NDA. And then there is the Slack community, and Slack was one of the things that we came across that was easy to do that. But other medium, Discord obviously is a great thing, and we're actually putting a server there, but I'm trying to map it so that we can have a replica of the information as well on the Discord side. But at the same time, we had actually, this number is a little old as well. It's now almost like 4,000 community members that are very interested in chip design and talking about it all over. And if you go to opensourcesilicon.dev, you will you will have a link or an ability to put your email in and actually sign up for Slack. And as I said, I realized that we were talking earlier about Discord, and we're actually working on creating a mirror through the Discord world so that we can engage more people everywhere. So now, next is the other type of simplification is that we actually provide the tools. So the tools are typically they're proprietary and very expensive. So one of the things we did with Google was to actually assemble an open source set of tools to make it available for people to design with digital and analog designs. One of the key flows that were developed was called OpenLane. OpenLane is a flow wrapped around another tool set called OpenRoad, which is a capability that actually enabled is a key enabler for the entire movement here. So we built a flow around it. But one of the conditions for that, we're working with Google, is that the team was there as a software team. Then we said, we don't know how to deal with what's in here. So we want it to be finished. So we want to input code and receive layout, something that is manufacturable. So thinking about it as a GNU compiler, that was the key part. And so, you don't have to make it optimize the best area or best performance. But if you think about it this way, like a GNU compiler, you can enable 1,000 more X at least, to people to use it, because you enable the software world to actually be able to use it to build something. There is also on the analog side, for those who are interested in analog designs, we also have the tools for that. We work with the community members. Different members are, around different parts of the world to develop a complete set of tools to do that. Why do the tools have to be open source other than it's cool? It's actually, again, coming back to the premise of open source, the limitless availability enables people to collaborate, and also it enables them to, when you have a spontaneous idea, you don't have to ask anyone to go try it. You can start exploring it and experimenting it, like exactly what you do in software. So here it is. You should be able to do that with for a chip architecture or chip design, and also collaborate with other people. Now, most of the chips that people build for things, they have a so-called the pad frame, which is it's basically the pins of the chip on the die, and these pins are this wall basically is a way to communicate between the tiny world of an inside a chip to the huge world of high loading and high capacitance outside the chip. This is the IO buffers. So, and also, if you're trying to build something like here in the middle, a function, this was time to digital converter. Now, if you want to build this, you're going to end up needing to build the entire thing to be able to try your own. So what we did is that we built a chip that exists, and your job is to design what goes in it, and then focus on it, and then automatically it gets merged into a chip, and then you get a board. So instead of getting a chip that is, you still have to build a system for it or software, there's actually, because we standardized the left side of this slide and made it available and accessible, then we can actually create a fixed a pin interface, and then you end up with having a board that you can actually, you connect it to the USB, and you start actually testing your own chip. And here's a little bit more information about that chip. It's called Caravelle. And if you go to github.com/Caravelle, you're going to find a lot of information about it, about the architecture, and you're going to find the very low code. Or there is some noise. If you could mute, please. So.
Yeah,
okay.
Sorry for the interruption. Yeah.
No problem. Thank you. So you're going to find the RTL code for it, and these are things that actually potentially can be targeted on FPGA for testing, etc. So in the slides, I'm providing links for these. So once we share the slides, and as I go forward, again, you get a board, and this is a board on my desk, and you can put it on there and measure things on it, and you get it ready. So this whole cycle basically simplifies the process. So instead of having to design the whole infrastructure, you just focus on designing your own idea inside that white area. And there are links here for where to start. Also, one of the more, to simplify the building of chips, we are working, and still not, this is not a mature concept yet outside in the open source. It's been used and applied within companies for years, decades, is to be able to have different functions in a sort of a library of blocks that you can actually drag them and put them together and connect them. So this will be in such a way that you don't need to know everything about what's inside block B or that blue block here. You can use it as a chip, and as a smaller, it's instead of a chip, you just put it inside your own chip and then hook it up and be able to use it. So think about it as, when you have Legos in them, you'll be able to assemble much easier. When the community started working on this, there are so many projects that came out, and these are just samples of the names. But if you go again to efabless.com/projects, you're going to find the projects and the links to the GitHub repositories, and you'll find so many interesting ways that the community chooses. We didn't tell people what to do. People decided to do these things, which is really good. This is actually one of the biggest advantages. And as we're going forward, we're trying to collaborate together to build more of the cores, add more processes like the global foundries, or work on. So the RISC-V is a big deal in this picture. So a lot of the projects you're going to find on the website, they're actually based on RISC-V cores that have been built, and from different places, different people, different applications, small and big, all the way. There's also the Open Power processor instruction set, which is architecture, which is the old, for those who remember, something called the Power PC, which is the original, one of the processors that were used for Apple computers and started, but that's actually an IBM architecture. They also opened it, and it's available in an open source framework. So open source has been used in many places. So when you have an open source design, there's actually an interesting component is that you can do work, you can look at it as a trust through transparency, because I can see what's in it. I can use it for security applications. And this is a very important piece, is that I can, here's an example of a collaboration with NEC, where some of these, one of our chips that is open source has been used for authentication, but it's small enough that an open source that can be inspected for Trojans and understood. You can understand what's in it, and that's actually a very big advantage. And it's going to take a lot of shape in the future, because of the connected devices need security and needs what's so-called the root of trust. So you'll find, having these projects that I was just showing here, open source, has a significant advantage. Where there's a need for verification, or you can actually verify it and inspect it for security application. So there are so many examples that are available, and you can these are microcontrollers that we developed before, and they're not on Sky 130 per se, but they were XFAB, but they were actually chips that are available also on GitHub. You can go see them. They were not fully open source because the PDK was not, but they are examples of chips that we built, and they were available. And on the two on the left here, it's called Raven and Ravenna. These are RISC-V microcontrollers, and the two on the right, the one on the top right is a ARM-based microcontroller, and the one on the bottom right is a test chip for analog. So simplifying the process also requires getting the barrier of cost removed. So this is the Google program where Google is funding free silicon for the community to try. And it is actually interesting because it's a lottery. There's no screening. Anyone can join, anyone can submit a design, and it's a true lottery, actually with a bias on one thing, how early do you submit your design? So if you submit your design 1 week before the deadline, you get one ticket in the lottery. If you submit it 5 weeks before the deadline, you get 5 tickets into the lottery. And if you miss one shuttle, automatically you become the earliest on the next one. So your chances of getting on that shuttle increases significantly. So it is actually uses the Caravelle chip, and you get boards and parts. And the condition for this is that everything has to be open source. And again, it is very important that this does not screen, so anyone can submit, and it doesn't matter whether you have a big design, small design, you should be able to go there. And I encourage everyone in this community to do that and try it, and collaborate together to build things. Examples of this, when we started, there were called MPW1. There were so many open, like 9 processor cores and 9 subsystems, SoC subsystems, and then there are, radio building blocks. There are embedded FPGAs. It was full, the first one. And then we also had individuals and companies, and you can see here the chip here, the main chip is there, but everyone has a different content in the white area. The very important slide that everyone should note of is that 60% of the people that did the work on this, on the first one, actually did not have the chip experience. And that's where I want to encourage you, is that, again, the first time we actually published this and opened it, first time, 60% of the people that showed up actually and finished, they did not have chip design experience. They came from the software side, they came from embedded hardware development, FPGA, etc. And then, that follows up with another one. And then we ended up basically until today, we just finished MPW 7. And again, this is just a picture of 1 and 2. But again, it shows you what different people do in all of these. They get the ability to test. And then we're running a little bit late on handing over the manufactured chips to people. So on MPW2, it actually is now, right now is about to be shipped to the designers where they can actually use and test. And then we did some cool things in collaboration with the community, including, our friend here, John McMaster, is able to etch and show, that we have added the open source hardware to the chip to world. The Google shuttle has always been full. Now we're getting here, this number is actually more in 6 and 7. You can see them on the website. And then you can see people sharing some cool things and sharing work. So we built an SRAM test chip. This is a community member, very active, Andrew Sonnenberg. He actually created a setup for testing the SRAM, and even including temperature cooling system. And then this is a student who built a switching regulator. It's a graduate student at Stanford. Great work. By the way, all open source. You can actually go and check it out and try it. And there are so many of these examples that are really cool. And then I'll leave it in the slides. We also, and this will, I'll hover through this very quickly, is that some of the startups they said, I don't want to open source my design. And some said, I want to get in, I don't want a lottery. I want to be able to be on the run and guarantee some schedule. So we created Chip Ignite, which is exactly the same process, but it has, a specific price that actually allows people to benefit from the design, this entire simplified process for businesses to be able to start a startup. So, and then I'll just hover through this quickly, and then because it says that $10,000, but that has nothing to do with the Google program. The Google program, you can actually do that at no cost. We enabled other options that some people don't need to use the microprocessor on chip, so they were enabling so-called an open frame. It's going to be available in November. And we have seen a lot of input from universities want to use it for teaching, courses, maker or clubs. They're very interested in that. And as I mentioned, startups as well. The main thing about this is that there are no legal agreements. You collaborate freely, and then you can start a design from existing designs and you move forward. The IEEE had a program last year. It's called Pico program. The Pico program, it was a global competition. And actually, here's the 11 projects that were finally selected. They were also published in the Solid Circuit magazine as a recognition of the open source activity, and it will continue to be so. So this was in November last year, and this is January this year, and there's more coming that I don't have here. The IEEE as well did the same thing. These are open source designs. You can look at the titles, and then when I send the slides, you can be able to see these projects one by one. Every one of them will have a summary about what the project is, and then the GitHub repository supporting that. Some people have, and the infamous Matt Venn zero to ASIC course. He actually created an exam, divided up the area and created 16 units inside that. This is not 16, but that's what he did. And that was actually a very good example of actually community innovation in both the business model and actually simplification, as well as the technology X. Recently, he actually introduced Tiny tape out. And for those of you who haven't seen that, I encourage you to go there. And Tiny tape out is it's a very interesting. He took the area, the white area in the design, which would be like something like on the top right here, and he divided it 500 times, like so it looks like this, and then and it has it's almost 500, but 100 micron. And about a small number of gates. And he created an interface, just again, a long simplification that actually happened through the community, something like his own creativity and working with, collaborating with others, like here, Walking We. So basically you can, here you design graphically, and you can put your own design, and by finishing and saving it, and exporting it, you actually designed a unit inside that 500 unit. So he created an interface and a tool, very small tool, very, very efficient to actually create that 500 or that 100 micron by 100 micron square. So this is actually a very interesting, and actually I suggest you actually take a look at it, because it's very powerful, and it has gained a lot of good traction. Yeah, so, and then we also address education, and we believe that, the more you simplify, the more you climb up the ladder of number of people, and also including software designers, and then you can get to the so-called Southern X. Now, the last thing, which is interesting, because I know there's a lot of, what we want to do also is to simplify it enough to actually get to the communities like Arduino, Raspberry Pi, and the general community of MicroPython. So this picture here is a representation of something that still doesn't happen. But one of the things that we're working on, and maybe people should actually be encouraged to do examples of these, is to be able to use something like ICE Studio for the Lattice FPGA to be able to directly go to create that block, the user block. And in a way, you can go use the iStudio, and then we do actually have a way. We have actually exercised the ability to use Python as an HDL, not just firmware or software, to define and come and generate a piece of the chip. And actually, as a matter of fact, this part of the chip here in the bottom, this was generated using Python through a framework called LiteX, or another name would be now called Amaranth, or using Amaranth. And I wanted to actually go do more of that. And actually, it'd be great to actually have the community to evolve some of these things and get ideas and build examples of this through the community, like what Matt Vin did. He created his own example here and his own work. It'd be actually the best way to do this is to actually have the community do these things with us. Lastly here, and I know we're running close to time, is that if someone is trying to build their own idea and it's not on Google, so still that number of dollars is still significant. So we started having conversations and good examples with two companies, GroupGets and CrowdSupply, for crowdfunding. And basically, you can define your own idea and put it in the market. And actually, if when you put it there and it gets funded, then you can actually make your own chip from the funding. The first example, we did it ourselves. It's called Clear. This is and we put inside the area of the chip, we put actually an open source FPGA. So it's actually an open source FPGA, but it's tiny, just to demonstrate the concept. And it was just, again, an initial program. It was modest. It was funded, funded enough to fund the development of a chip, as well as the delivery of the boards. We had a first generation of it, but now we're putting the second generation on Clear. There's also other examples, like if you're examples of this. If you go to CrowdSupply, CrowdSupply has there's a program that is about to be released. It's called Maverick. And actually here, if you browse the projects and go to pre-launch, actually it is here. So basically Maverick 603, it's an amateur radio FT8 receiver, okay? And this is about to be launched, and the designer of that stack, it's called Radio Stack, and Colby along with Ryan, they work together and other community members to develop a complete board that as a receiver, and the Caravelle chip will fit right here. So they are designing that and actually using the funding from the crowdfunding to develop their own chip. So I encourage you to take a look at that as well. And then, and I mentioned that. And lastly, as I mentioned, for startups, they can do these things. And I'll leave it here with a bunch of links for you to join or to take a look at and start the path for making your own. Thank you.
Yeah, thanks, Kasim. Thanks for sharing the wonderful session about the chip designing and how we can get it started. So I actually have a few questions from participants. I'm just go through. Okay, the first one from Abdul Wadid. Okay, so what is good for any company to open source a PDK that might have developed by investing a lot of money, time, right? So I think Abdul Wahad getting an explanation of why the companies like Google and SkyWater are actually open sourcing their PDK and what benefits actually they're getting.
Okay, so let's talk. There are two separate benefits. So one, let's talk about the foundry. So SkyWater. So SkyWater, when they open source the PDK, that means more people have access to their technology and they can use it to build chips. So ultimately, over time, that means that the users of SkyWater have increased, and some of them will create chips, and that's business for them. So the opening the PDK is simply the least benefit is just good business, is that more people are going to use it, and then some of these people are going to actually make products that around SkyWater. The other indirect aspect here is that from SkyWater to open the process, the PDK, the innovation vector. There will be things that are developed on SkyWater that are as a result of the community collaboration that also never would existed without the community. From a Google perspective, it's very simple. The group that we're working on is interested in building an ecosystem for chip design that is open source, that allows, if you started today, think about what happened in Linux. Over the years, it became a robust outcome that people can use it for their products and commercially. So Google is interested in improving, making better, faster, cheaper chips. That's why they're interested in seeding that and starting it. Basically, if you don't start, it's not going to happen. And that has been a great collaboration, a great team on the Google side.
Yeah, thanks for the answer. That actually makes totally makes sense. And also, I believe there is a lot of like a resource gap between the companies and who need so many designers and the current market, right? So they also need to fill the gap with to give people the right tool, to educate them how to use the tool, then get back to the company. Yeah, that makes sense.
Yes.
Yeah. And we have another question from Nelson. Is OpenLine supporting the new PDKs available GF and FD 90 nanometer?
So the FD 90 nanometer is still to be developed. It's not out yet, but OpenLane for global foundries will be out in basically around end of October. So give it a month. Okay. But it is available for, it's being finished, it's being used for a chip, and it's going to be available in a few weeks.
Yeah.
And
perfect.
there will be shuttles, Google shuttles available for 180 nanometer.
Okay, cool. Perfect. And we have 3 more questions. Okay. So like another question from Nick, where do you see the market share of silicon developer in the way of going? I know it's expanded, but what scale are we looking at? I think he's mentioning about MPW program. What about the scalability of the MPW program, etc.? So once, yeah.
So to be I don't know. The word honest is so the Google program. It's a program that is funded by Google to stimulate innovation. I look at the Google program as a jump starter, and it would continue. Thankfully, Google is, the team is great and has been interested in actually doing multiple projects. But if you actually looked at the third one, that's 90 nanometer, Google actually took a big part of that we worked with them in SkyWater. The government, the US government, is funding the third round. So it is not, it's not only Google, it's actually the government, it's the US government. And it is open source, so it's doing it, it's available everywhere. But that's another funding source, interested party that did that. Then lastly, I believe in general, commercialization is the ultimate sustainable model. So that's why I was talking about Chip Ignite and the ability to crowdfund. So, that's where this funding would always be market driven. If you have an idea, publish it and get it. If you get it crowdfunded, then you solve your problem. You solve a problem for a customer, and then you can do your own, and you don't need funding from a third party.
Yeah, that makes sense. Thanks for sharing. Yeah. And also from the pandemic, we actually all world understand how important chips are actually in daily lives of humans, right? Because all things are stuck. The car manufacturing, computer manufacturing, price actually goes high. Everything was stuck. Yeah.
Yep.
Cool. And also right now, as you mentioned, all government actually trying to make a knowledge base in their country and try to make foundries in their country, and they're competing each other to make like a kind of a sustainability in the chip designs and manufacturing. Yeah.
Cool. Exactly.
And we have 2 more questions. One that's also from Wadid. How many MPWs are actually potentially coming in the future? So right now, as you mentioned, almost all the MPWs are full, right? So what are the possibility of MPWs are that actually planning to in the future?
So for the foreseeable future, every other month, roughly, there will be an MPW on SkyWater.
Mhm.
So we just finished MPW 7. The door was closed, so there will be soon open the door for MPW 8, and it will continue. So unless something major happens on the planet, it's looking like, you know, every 4 times a year at least Google will fund on that process, and then we will the 180 nanometer project MPW will be added. So there will be plenty. I would call it almost 6 next year probably, or more across the 2 processes.
Yeah, that's great. That actually a good news for those who are actually starting designing and learning. So very
Exactly.
motivation.
And actually, just I'll tell you, the more people get involved, the more the Google program will get fuel to fund more.
Yeah, that's it. That's actually good news. Yeah. And we have one more last question for the today's session. Like, what are the resources available to help with the design of AMPs, ADC, DAC, etc.? So it's kind of a general questions, I believe. Yeah.
What other what?
What are the design or resources available to help with the, like designing kind of a op-amps, ADC, DAC inside the microcontrollers?
Well, one of the very important things again is the Slack community, and also if you go to the efabless.com/projects, you're going to find analog projects and already existing, very experienced people who develop something and put it open source that you can take a look at and learn from it. The good thing about it, it's open. You can actually have it and simulate it and understand where a designer came from. Some of them don't have enough data. You feel free to ping the designer and find him on Slack and ask him the questions. It is actually something that's never happened before, and you can do that. And there's no question that is too simple. It's just ask, and people, you know, you'll find the community amazingly helpful because everybody wants to help.
Yeah, great. And also I would like to add, like Accomdemy actually running as a special interest group for this chip designing. So we are actually planning to, like as part of today's session also, we are planning to gather the people who are interested in chip designing and having some kind of a like accompanying design in the chips, because from our Taiwan community, members are already experienced with PCB, like a PCB design and chip design, etc. So we are trying to learn each other, just sharing our knowledge a little bit. So if you're interested in more about it, you can also join on the Discord that share on the chat.
We would be happy to stimulate some of these discussions in a way as well. And by the way, I want to mention something else I forgot to mention. So I see here our friends from BSD. There's Anna Ghosh and Kunal Ghosh. They have they've created an incredible background and effort around jump starting and training the open source design, and also not open source, but it is, in my opinion, the best comprehensive curriculum actually around the different things, analog and digital as well. And also I encourage you again to go to Matt Ben's A02 ASIC course and tiny tape out for those who want to try something very very small. And among all this, between Efabless and the community, and VSD and 02 ASIC, you'll find enough information or enough help to jumpstart you and put you in the right place wherever you want, either a beginner or an advanced. It's all available. And as I said, the community here, the beauty of it is that everyone enjoys helping other people.
Yeah, awesome. And I'm very happy to meet them. Like I just get a message from Anaga and sharing their project. So that's great. We can share with our community. So the main goal is to learn, to teach others also to design the chip, because we know like there is a huge gap between the demand and the supply. So we want to fill them, and also it's kind of a maker instinct to learn new things and understand how the things are working. So yeah, that's great. Over to you, Paul. Would like to add?
Yeah, really appreciate Mohamed did a very great sharing, and I really get inspired by the initial idea of the Stone Soup Lab. So I think we also have the same vision in Accomdemy, is that we want to make people they can learn together and conquer all the difficulties. So just want to do a very quick survey. So if you are a beginner of this topic, you can please type like +1 in the chat. Or if you are already have the experience designing your chip, you can type +2 in the chat. Okay, that's aligned with the Mohamed just said that 60% of people they are beginners for this program, and we really have the vision that building a world that everyone can design their own chip. So that's the reason we have the online learning series, which is in 10 weeks, people they just group together and learn how to write Verilog and how to design their RISC-V based CPU. So that's totally insane for me that even like some senior high school student, they join. So happy to let everyone, if you just, no matter you are beginners or you are senior, we can learn together. And if you are a beginner, don't worry, that we can learn together. And now we are also trying to build a Moodle system, which is allowing all the beginners can learn step by step. We know that it's always very like overwhelming that a lot of information online. And as Mohamed just said, you can go to GitHub and take a look, but there are too many information. So we want to like using the power of the community that we do like a very simple tutorial guide and let everyone who are interested in and can step from zero. And we can also share this to the whole community, including like Google Efabless and even everyone they are interested in this topic. That's something that we really want to do. So also Selman just shared the link of the Discord. So if you are interested in participating in this kind of online study group, you can join the Discord group and please say hi in the self-intro channel. Mohamed, you can also join this international Discord because the one I share with you, that one was for Taiwan. So most of the
I will.
Yeah, so most of the discussion was in Mandarin, but we built this Discord for international members. So you can join and say hello in the self-introduction channel, and let's group together to like to learn the design of that. So just want to make everyone can have a roughly idea about that. So currently, community members, we have some ideas that we are thinking to design a chip to support the smart camera. That is something that we have the idea in mind. Or even like we can do some like because some of our evangelists they are also in the crypto area, so we are also thinking that we can build some project based on like data transactions and combine with the crypto. So that's very cool. So if you are interested in that, join the Discord and let's keep the discussion there.
Yeah, and we can also discuss like if you have any potential ideas that actually we can make this chip design, can also share. And there is no like a wrong questions. You can share what you like about chip, and we can discuss and we can conclude. Yeah,
yep.
Yeah, awesome, great.
Okay. Any last questions? If no, then I think that's it for today, and really appreciate Mohamed, Selman, and everyone